some tuning forks have a really low pitch and some have a really high pitch. So these are two tuning forks, and I think, yeah, so this has a low pitch and this has a high pitch, but these lengths of the iron in the tuning fork depend vary the pitch. Let's find out. So let's just listen to these two tuning forks and let's see how they sound. So let's try the low one first. Still going on. Although it may be too faint, it's still going on right now. Yeah, it's still going on. But now let's try with the high pitch. So I'm already faint. Yeah, now it stopped. So, do these lengths of the tuning fork make any difference? That's a question we might try to answer today. And do these lengths again vary the pitch? Let's try to find that out too. So there are many questions that will spring up on tuning forks, and I'll try to answer as many of them as I can. So here is a sound wave, and we'll try to find out what are the characteristics of a sound wave. So as you can see, there's a height of the wave, right? And then apart from that, there's also a length of the wave. And then there's also the number of waves in a second, right? So all of these have terms. So the height of the wave, so let's first draw a line across. So then the height of the wave from that line will be called the amplitude. So the higher the higher the amplitude, the louder a sound is. And then the length of the wave is just up and down. So that is called a wavelength. So each up and down is called a wavelength. So that is a wavelength. Now, wavelength, the shorter the wavelength, the more waves that can fit into a second. So that means that the number of waves per second is related to the wavelength of the sound. So that means, so the shorter the wavelength, more number of waves in a second, that means a higher frequency because there are more oscillations per second. And the higher the wavelength, that means fewer waves in the sound, and that means a lower frequency. So how do tuning forks work? How do they make sound? So the tines, or those two metal bars which are part of the tuning fork, when they're hit against an object, they start vibrating. And they vibrate at such a speed that they can compress and decompress the air around them, thus making a sound wave. Now, the length of these tines can vary, and thus the amount of vibrations too can vary, and thus they make different types of sounds of different pitches. Now, let's see the amazing experiments that can be done using the tuning forks. Now, let's listen to how all the tuning forks sound like. Now, let's see how the vibrations of a tuning fork can affect the particles around it. So, in this case, we'll be using some water. Now let's observe how all these the three tuning forks can affect the particles around it. Here let's take a top view of it.